Let's go to page 153, and let's do number 174. So this one you have the picture giving. And you have the midpoint over here. This is A, B, C, D. And it says that, okay, angle A is 30 degrees and DBC is 45 degrees. And AB equal to 3 minus square root of 3. And you're looking for the area of BCD. You're looking for this area over here. Okay, so first, since this is 45 degree, 45 triangle, so these two are congruent. So I'm going to label this as an X. And this is a 30-60 spatial triangle. So the long leg would be square root of 3 times that. So the long leg, so this is the long leg, will equal to square root of 3 times the short leg. Okay, and I'm going to move the variable, I'm going to move this over. So minus x. So 3 minus square root of 3x equal to square root of 3x minus x. Go and factor out the x. And then you divide. And this is kind of messy, so I'm going to simplify. But before I do that, let's go and flip this over. To simplify, you multiply by the conjugate. So when you multiply, you're going to get 3 minus 1. On the top, you're going to get 3 square root of 3 plus 3 minus 3 minus square root of 3. Okay, so when you simplify, this cancel out. This minus I give you 2 square root of 3. On the denominator you get 2, and this cancel out, so x equal to square root of 3. Once you find x equal to square root of 3, then the area is very easy. So use k, because a is already taken, so k as an area will be 1/2 base times height. Okay, so let's go and substitute. So k equal to 1/2 square root of 3, square root of 3. So k equal to 3 over 2. Okay, let's go to 175. Okay, so you have a triangle ABC, and the perpendicular bisector of the two sides of the triangle meet in. Okay, so let's get the perpendicular bisector. Okay, and this perpendicular bisector . Okay, so one thing you need to remember is that the perpendicular bisector of a triangle meet in a point called the circumcenter. That means this point is the center of the circle that goes around that. Okay, so you can perpendicular bisector of a triangle meet at a circumcenter. And this one meet right over here. So this is a circumcenter. Now since this is the circumcenter, that means this is going to be the radius. This is going to be the diameter. And if this is the diameter, this arc, so arc AB is equal to 180 degrees. Then angle C angle C would be the half of, because this is the inscribed angle, so it would be half of that, so equal to 90 degrees. Okay? And therefore, the angle C is a right angle. Okay, and that's it. So again, that's going to be summarized. The perpendicular bisector of the triangle meet at one point, and that's the circumcenter. That's the center of the circle that goes around. And it tells you that this meet on the midpoint of the third side. Okay, so it meets right over here. Now, since it meets on this side, that means this becomes the diameter of the circle. And if this is the diameter of the circle, then this arc is 180. And if this is 180, the inscribed angle is half, so it will be 90. Therefore, this is the right angle. Okay, let's go to page 154, number 176. So this one, you want to prove that 1 over HA is less than 1 over HB plus 1 over HC. Okay, so you want to prove that 1 over HA is less than 1 over HB plus 1 over HC. So HA is the altitude to the side A. This is the altitude to the side B, altitude to the side C. So what we're going to do is we're going to start with the inequality theorem. So A is less than B plus C. So for any triangle, any side would be less than sum of the other two. Okay. And so what we're going to do also, we're going to use using the area. Whenever you talk about altitude, you kind of have to think about area. So I'm going to use K because A is one of the angle and the side. So area of a triangle equal to 1/2 the base or the side A times the height. Okay, again, altitude is the height. Okay, so area is 1/2 base times height. It also equal to 1/2 side B times height, which is HB. And K is also equal to 1/2 the base, which is the side C, times HC. Okay, so 1/2 base times height, 1/2 base times height, 1/2 base times height. Okay. Then from here, I'm going to solve for each side. So 2K over HA equal to A. Over here, 2K over HB equal to B. Over here, 2K over HC equal to C. Then I'm going to substitute all this into here. So I get 2K over HA is less than 2K over HB plus 2K over HC. Then I'm going to divide everything by every term by 2K, so I get 1 over HA is less than 1 over HB plus 1 over HC. And that's what we prove, right? So that's it. Okay. Okay, let's go to 177. Okay, so you have a triangle A, B, C, and angle C equal to 90 degrees, and it says sine A equal to 7 over 25. Now sine A, sine A is the opposite of a hypotenuse, so it would be 7 over 25. Now, one you have to be careful is that this is a ratio, so this is not the actual length, because the length can be 70 and 250, for example. Okay, so we don't know what original length is, but in this case, it doesn't matter. Okay, because we're just using it to find the other trig functions, trig ratios. So this is your spatial triangle, so 7, 24, 25. Okay, so you recognize that. So and you're looking for sine B. So sine B, you have to use this angle, so you have to kind of turn around this way. So sine is opposite of a hypotenuse, right? So it'd be 24 over 25. And you're looking for cosine A. Cosine A would be just this over there, so it'd be 24 over 25. And you're looking for cotangent A. So here's your angle A. So tangent is sine over cosine. Cotangent would be this over there, so it'd be 24 over 7. And you're looking for cosecant of B. Now cosecant came from sine. So look over here. So B is this way. And so sine is this over that, right? And cosecant would be this over this. So cosecant of B would be 25 over 24. Okay. So again, look at this one over here. So cosecant came from sine. So sine is this over that. So cosecant is this over this. And so that's what you get. Okay, let's go to 178. So 178, they give you this picture. So let's go and draw the picture. This one. Okay, let's draw this way. Okay, so you have the triangle A, B, C, and then you have the altitude H, and you have the midpoint, the median, okay, then let's see what else do we know. Okay, so the angle between CM and the hypotenuse AB is equal to 30 degrees. So this is 30 degrees. And you're looking for the area of ABC if the altitude, this is like a, this is the C. And this is the B. Okay, there we go. So CH is equal to 4. So you're looking for area of ABC. Okay. So again, this is the median. So whenever you have median to the hypotenuse of the right triangle, this will be congruent. Just be aware of that. Okay. So look at this triangle right over here. This is a right angle, and this is 30, so this is 60 degrees. So this is your 30-60 spatial triangle. So if there's a short leg, this is short leg because it's facing the 30 degrees. So if the short leg is 4, then the hypotenuse would be 8. And because this is the midpoint of the hypotenuse, so this point is equidistant to all 3 vertices. So if this is 8, this would be 8, and this would be 8. And this 8 is from here to here, right? Therefore, AB, this whole length, the hypotenuse will be equal to 16. So now we have the base, we have the height, we can figure out the area. So K equal to 1/2 the base times the height. So the area is equal to 32. Okay, so again, once you recognize that the midpoint of the hypotenuse of the right triangle is equidistant to 3 vertices, so all these are congruent, then things is very easy. Okay, let's go to 179. Okay, so you have this triangle here. You have triangle, let's label ABC, and you have 2 medians that are parallel, or the base is 15, and you have the 2 parallel lines that divide the area into 3 equal areas. So the area, let's just call this 1, 1, 1. Okay, so 3 equal areas, and you're looking for this length of this, you're looking for the length of this parallel line. Okay. So I'm going to call this D, and this is E. Okay, so the area ratio of triangle ADE to triangle ABC. Okay, so this is going to be equal to 2 to 3. Okay, so area ratio of this triangle to this triangle is 2 to 3. So therefore the scale factor, remember this is two-dimensional, and so the scale factor okay, you have to take the square root. Okay, so the scale factor would be of these two, of the length of the DE to BC would be square root, so it would be square root of 2 to square root of 3. Okay. So now you're looking for the x, right? So that will be same as x to the 15. Okay. And therefore now you can go ahead and get your equation. So square root of 2 over x equal to square root of 3 over 15. Okay. And then after you crisscross, so square root of 3x equal to 15 square root of 2 divided by square root of 3. So this will cancel out. Now to simplify this, you go and multiply by square root of 3 over square root of 3. So you get 15 square root of 6 over 3, and you simplify, so x equal to 5 square root of 6. Okay, and that's it for this one. Okay, let's go to 180. Okay, so you have length AB. It's divided so that the ratio of this is 3 to 1.
Taylor Gonzalez to the upper school office, please. Taylor Gonzalez to the upper school office.
And then you're going to draw circles. So you draw 2 circles. Okay. And then you're going to extend the AB, and then you're going to draw the common tangent, and this point is D. And you're looking for BD. I'm going to label it as X. Okay, in terms of the radius, so this would be R and this would be R. Okay, now because this is this is the ratio of the AC, it's 3 times that, so this would be 3 times. So everything would be 3 times. So this would be 3R and 3R. So to do this problem, what you need to do is you need to go and draw the radius from the center to the tangent line. Okay. So you have a right triangle here, you have right triangle here. So all this would be similar triangle. And so you can go and use your ratio. Okay. So if you're going to have for example, if you have the small over big, so if you have the R over 3R, so this over this will equal to this over this. So equal to R plus X over this, which would be 5R plus X. Okay, so again, so this over this equal to this over this, right? So that shows a similar triangle. Now next, go ahead and cross multiply to solve. So you got 5R squared plus RX equal to 3R squared plus 3RX. And let's go and move this over. So minus 3R squared. So this will cancel out and move this over, so minus Rx. So this cancel out. So you got 2R squared equal to 2Rx. To solve for x, you divide by 2r, so x equal to r. Okay, let's go to 181. Okay, so you have this triangle A, B, C, and you join two medians. I'm going to label it E and D. And what you're going to do is, next is you're going to go and use AD and BE to form a new triangle. Okay, so rotate, so this is A, D, and this one rotates, so you get E, B. Okay, and so you're looking for what is this over here. Okay, well, this is a, if you apply the Pythagorean theorem, this will equal to, so what you're looking for is equal to square root of, use Pythagorean theorem, right? So A squared plus B squared equal to C squared, so it would be square root of this square plus that, right? So it would be AD squared plus BE. So AD squared plus BE squared, and you take the square root, that will give you this length, okay? But what are these equal to? Well, to find what this equal to, you have to kind of come over here to use the triangle to find out what those things are, right? Okay, so for a triangle, so if you triangle ACD, so ACD right over here, okay, then you're going to get AC squared plus CD squared equal to AD squared, right? But what's CD? Because you don't have any CD over here, the CD is one half of the BC. So AC squared, so CD is 1/2 BC. Okay. So we find these, right? See, AD squared is this. So we know we find this. But we need to find this one. So we need to get another triangle. So if you use a triangle BCE, so this one over here, so you're going to get EC squared plus BC squared. It will give you BE squared, right? Pythagorean theorem for that. But what's EC? Well, EC is 1/2 AC, right? Okay. So now we can substitute this into here, okay? So question mark equal to square root of, so AD squared is AC squared plus 1/2 BC squared. And BE squared is from here is 1/2 AC squared plus BC squared. Okay. Then after that, you can go ahead and simplify. So this over here, when you multiply out and you simplify, you're going to get, so when you square, you get 1/2 squared is 1/4. 1/4 plus 1 will give you 5/4. Same thing over here, right? 1/2 squared is 1/4. 1/4 plus 1 is 5/4. Okay, and I'm gonna factor out the 5/4. Put parentheses around this thing. Okay. And I'm going to separate the two square roots. and this becomes 2, right? Okay, but now if you look original over here, right? What's the AC squared plus BC squared? See, AC squared plus BC squared is what? It's AB squared, right? Okay, so the question mark would be equal to square root of 5 over 2, and this would becomes the AB square, right, using Pythagorean theorem. And now you have square and square, you can cancel out, right? So the question mark will equal to square root of 5 over 2 AB.